Welcome to Easy Math TV. This is part 2 on your introduction to the standard normal distribution. Just to recap, we have a random variable which we denote with capital Z, and it measures how many standard deviations away from a mean you are. So if you're right at the mean, then your Z-score is a 0 because you're there, you're at the mean. So a Z-value of 0 means that is the mean, and then a Z-value of -1 is one standard deviation below the mean, and then a Z-value of +1 would be one standard deviation above the mean. So basically, everything is measuring how many standard deviations away from the mean you are. And then last time we used Excel formulas, built-in Excel formulas, to calculate probabilities for these. So if you recall in previous videos, we've talked about continuous random variables. Whenever you have a continuous random variable, probabilities are always areas under the curve, areas under your probability distribution function. Okay, so you can only talk about areas or probabilities of intervals, probabilities of like between two values of z. So you see those probabilities are here. These are all probabilities between two values of z. Then you've got probabilities to the right of a value of z. Those are here. You have probabilities to the left of a value of z. Those are all here. So so we went through all of those, and that's pretty much like those are all the different possibilities that you would run into. You're either going to be less than a value, greater than a value, or in between two values. So so these are calculated for us based on some the more commonly used values of z. So we did these calculations for all of the integer values of z, -3 up to +3. Okay, so that's just recapping what we did last time. So let's talk about the empirical rule. The empirical rule is associated with those values of z that you see in column B there. And it gives us the probabilities of being within one standard deviation of the mean, or two standard deviations of the mean, or three standard deviations of the mean. So again, that's in between two values. So basically 68.27% of the time, you are between -1 and +1. And we calculated that down here in G9. I just added those two numbers up in rows 4 and 6. So basically -1 to 0 and then 0 to 1. Just add those two numbers up. Equals F4 plus F6. When you add those two numbers, you get all of the outcomes between -1 and +1, which is happening 68.27% of the time. The next value is within two standard deviations of the mean. So that's all four of these numbers that you see highlighted here, from -2 all the way up to +2. And again, we have to add those probabilities up. So down here in cell H9, I added F3 plus F4 plus F6 plus F7. You add those probabilities, and you basically get 0.9545, which is 95.45% of the time. So 95.45% of all outcomes will be within two standard deviations of the mean. When you expand out to three standard deviations, so between -3 and +3, and you add all these numbers up, you actually get close to 100%. You get 99.73% of all of your outcomes are within three standard deviations of the mean when you are dealing with a normally distributed random variable. So I calculated that by just using the sum formula equals sum and parenthesis F2 colon F8. So that's the empirical rule. The first number, it gives you the percentage within one standard deviation of the mean. So centered at the mean, but like going out to +1 and -1. That's 68.27% of all values. 95% are going to be within 2 standard deviations, and 99.7% are within 3 standard deviations. So that's all well and good, but how does that translate into real world values? Because we don't measure things in the real world with values of z. We measure them with x. So here's an example for you. Suppose that x is a normally distributed random variable with a mean of 1,100 and a standard deviation of 200. So these are SAT scores. And before we get into answering these problems, let's not answer the problems just yet. Let's just get our values of x that correspond to these values of z. Let's get them into our spreadsheet here. So the first number you want to type in is here in K5. That's your mean mu. Okay, so the mean mu is 1100, and that gets typed into K5. And then down here, the value of sigma gets typed into K10. K10. All right, so I'm going to move this little thing over a little bit because we're going to need to anchor things. Okay, so starting with your mean, starting with the center value of 1100, you either add sigma to get to on the plus side, or you subtract sigma to get on the negative side. So those values, if you look at the graph down here, those values correspond to values that are either on the positive side of the mean or on the negative side of the mean. So think of the x1 here as 1 standard deviation away from mu. Mu is right at the middle. So 1100 would be this value of mu down here. 1300 would be your x1, and 1500 would be your x2. So x2 is like 2 standard deviations away, okay? And so they correspond with values of z, because the shape of the curve is precisely the same. It's exactly the same. It's just that x values are on a different scale, z values are on a slightly different scale than x, okay? So we have to convert between the two. All right, so just real quick, to fill in the rest of this chart, then in cell K6, you would type equals K5 plus K $10. You use a fixed reference if you want to just fill down. So again, that's equals K5 plus K $10, and that's going into cell K6. And I can click on that anchor and fill down to just down to row 8. So it's just these 3 values here from K6 to K8. And then on the negative side, you would have to subtract. So in K4, you're going to type equals K5 minus K $10, because you're subtracting the standard deviation from the mean. And again, you can click on that anchor and fill up. So down here on our graph, you could actually fill in those numbers if you wanted to, that are 1 standard deviation, 2 standard deviations, 3 standard deviations away. And you would start with 500, then 700, then 900, then 1100 would be right here in the middle, and then 1300, 1500, 1700. So those are the values of x in this situation. So just when we're talking about SAT scores, these are the x values that correspond to these integer values of z. They measure 3 standard deviations away from the mean, 2 standard deviations away, and so on, right? how many standard deviations away from the mean are you? Well, we're going to talk about that in let's look at a couple of problems and see if we can answer some questions concerning our SAT scores. So problem 1 states what SAT score occurs about 68% of the time with 1100 at the center. So let me go over here and move this back over into our column. And using the empirical rule, 68% of our numbers lie between one standard deviation from the mean. One standard deviation. And we just calculated those numbers to be 900 and 1300. So the answer to that problem number 1 is 900 and 1300. Problem number 2, what is the percentile of an SAT score of 1300? So for that, we need to look at our percentiles column. The percentiles are found in column C because they are calculated areas corresponding to those z-scores. We know how to calculate those areas. We do not know how to calculate areas of SAT scores. So that's why we have to kind of go back and forth, okay? Since the number 1300 has a z-score of, or has a z-value of 1.0, then the percentile is the cumulative probability at a z-value of 1, so that's got to be 0.8413. Okay? So whenever you're being asked a percentile for a value of x, the way to calculate that is to get the percentile for the corresponding value of z. And I'll just close with this statement down here. When asked how many standard deviations from the mean is an SAT score. So let's say you have a specific value of x, and you're saying how many standard deviations away from the mean is that? The answer is a z-value. So like how many standard deviations is a z-value? So since we know what that number is for 1500, because 1500 is on our table here, and all we have to do is look across from it. 1500 corresponds to a z-value of 2. So the answer to that question of how many standard deviations it is, the answer is 2. It's 2 standard deviations away from the mean. As a general rule, though, you can calculate the z-value by taking your value of x minus mu, so subtract mu, and then divide by sigma. Again, you can find a z-value for any value of x. So no matter what the x is, it doesn't have to be on this chart. These are just very special values of x here. But if you happen to be given a different value, say maybe 1050, 1050, how would you calculate the z-value for that? You take your x value, which is 1050, subtract mu, which is 1100, and then divide by sigma, which is 200. And that will tell you what its z-value is. Okay, so that's your general formula for converting from a value of x to a value of z. However, we have very special ones that are on our table. So that's your introduction to the standard normal distribution. There are more videos on this topic, so I hope you'll check them out. Like, subscribe, comment down below. Make sure you share these videos with people that you think might find them useful, and I'll see you in the next video.